So finally, once we have this, we can go ahead and start working on the solver. That's the interesting part. For the solver, we want the changes to start happening only after frame 1040. So that's the first thing I'm going to do. So we have the input coming in. We have the previous frame. And I'm just going to create a switch here. So before frame, let's have this here, the previous frame here. So we will only process the geometry after frame 1014. Next, we will have a point wrangle. And in this case, often, or in most cases, you will just use the previous frame to process the geometry from the previous frame. But in this case, because the geometry is being animated, we can either process the geometry here and update position, or we can process this geometry, the input geometry, and based on the previous frame. And that's what I'm going to do in this case. So I'm going to go here, here, and this goes here. This will be the actual growth happening. So the first thing on this growth algorithm that we're going to be using, and there are many different ways of doing this, and you can find several tutorials on this for sure, but I'm going to do it in a way that I think it's working pretty well for this particular situation. So it's going to be based on the idea that each point has a few neighbors, and if the density of my neighbors increases, my density will also increase. That's the main logic behind this. So the first thing I need to do is kind of have a way of measuring or accumulating how much density my neighbors have. So we'll start with a float called density dense accumulated. And the original value, whenever we start the algorithm for one point, the density accumulated is 0. Next, I need to know how many neighbors I have. So let's create a int nays. So in this case, it's an array of all the point numbers of my neighbors. It's going to be equal to neighbors 0 at ptnum. Here we could use either 0 or 1. Both have the same number of points, so it's exactly the same thing. It wouldn't make any difference. Next, I want to check what's my neighbors count, how many neighbors I have. That's also important. So I'll use nays count. It's going to be equal to the length of that array. Okay. Length nays, my nays. Okay, so now I know who are my neighbors and how many neighbors I have. Now I need to go through all those neighbors and measure their density and accumulate that density. So what I'll do is I'll create a for loop to go through my neighbors. So for int n equals 0. This is going to be the variable that's going to be changing throughout the for loop. The condition is that this for loop will stop, will go until my n number is lower than my neighbors count. As long as it's lower, it keeps going. And once it goes through, every time it goes through, it increases n by 1. Okay, this is what this means. So for every n number starting at 0, while n is lower than the neighbors count, my neighbors count, go through and do something, and at the end increase that n number by 1. Let's create a space for what's going to happen, and this is pretty straightforward. The accumulated density the float variable that we created before. It's going to be equal to, or it's going to be plus equal. We're going to be accumulating to what we already have. It's going to be plus equal the density of my first neighbor. Let's density my nays, and I'm grabbing the point number that's on the list of my neighbors. Okay, my nays, my neighbors, my neighbors, my neighbors. Okay, so this is a way for me to reference the on the array we have a list of numbers, and on the first iteration of this for loop we will grab position 0, on the second we'll grab position 1, and on each one of these positions I will have an ID, a point number that will for which that will correspond to one of my neighbors, and that's where I want to get the density from. Then we will multiply that density by the growth variable, the second variable that will kind of weigh how much influence that the density of that point will have for calculating this density. So I'll use point. Same thing. So one, I'll be grabbing growth, and the same thing. So I'm just going to copy this, Control C, Control V. Okay, so I'm grabbing the density of my neighbor and then I'm multiplying it by its growth value. And that will kind of create some variations on the surface, and you'll see what I mean. Next, if once we have that accumulated density, I want to kind of average that accumulated density by the number of neighbors that I have. Otherwise, it would be pretty drastic. The growth would be much, much faster. We can give that a try, but let's start with doing how it's supposed to be. So divided equal, this is the same as having, it's going to be equal to dense accum divided by the nays count. But instead of writing this variable name 2 times, you can just do this, and it's exactly the same thing. Same as plus equals, minus equals, all that. And finally, my density is going to be equal to my density. And this is, again, something we could do like this, plus equals dense accum. This is the main principle, but because we want to make sure that the density doesn't go over 0, or doesn't go below 0 or above 1, we would then have to say that f density is going to be equal to f density clamp. So instead, what I'm going to do here is I'm going to say it's here f at density plus density accumulated, and then we clamp this between 0 and 1. And we have our algorithm. So going over it again, for each one of these points, we reset the accumulated density. We check which neighbors, who are my neighbors, and how many neighbors I have. Then for each one of those neighbors, I'm going to be accumulating the density of that neighbor times the growth value of that neighbor. Once I have everything accumulated, once I have gone through all my neighbors, I will then average out that density, that accumulated density, by dividing the accumulated density by the number of neighbors I have. And finally, I will add that to my current density, making sure to clamp it between 0 and 1. Let's go up. And I know for a fact that the substeps of 1, it's going to be a very slow growth, but for now, let's just go with that. Let's move on to frame 1058. The thing that I want to make sure is turn this on and control middle mouse button. Let's have a look at density. And on density, I'm gonna right click here and make sure, not growth, right click and make sure that density actually has a minimum and a maximum. Okay, that's something that I really want to make sure. So we have nothing going on. There's that density there, which is positive, and I really don't want that. So I'm going to make sure that we reset the density on this side. I'm going to call this 0 density. So while we're not going through the algorithm, I want to make sure that everything is density 0. Okay, let's go give it another try.